So this session is related to the topic metallic bonding. So we'll solve most of the questions related to metallic bonding. You can also participate. So the diagram represents the journal structure. So when we check the journal structure, because in a metal we have an arrangement of a positive ion and the free electrons. So basically this is a structure of metal. If it was a structure of ionic compound, then how the structure will appear? Because in ionic compound we have a lattice of oppositely charged ion, like we have positive and negative ions arranged in a regular pattern. So it will be positive, negative, positive, negative, positive, negative, and positive, negative. So this is the structure of ionic compound. But in case of metal, there is a lattice of the positive ion, and these are the free electrons. Like these electron can move anywhere. So when we check which one is a metal, so aluminum is a metal. That's why this is a structure of aluminum. Why not iodine? Because iodine is a simple, it's a non-metal. Non-metal, how they structure, they have a covalent bond or they have a sharing of electrons. So if it was a non-metal, it will have a sharing of electron or it will be a covalent. Ionic means it's a combination of metal and non-metal. So it cannot be iodine. Silicon 4 oxide, it's a macromolecular structure, a giant structure, so it cannot be. And sulfur, again, it is a non-metal, so none of them. B, C, and D are totally wrong. That's why A, which is a structure of metal, is the right answer. In question 2, metal consists of a lattice of a positive ion in a sea of electron. Why metals are malleable? Malleable means we can hammer them into shape. Like if we have a metal, we can hammer this metal, we can hit this metal with a hammer, and we can make into certain shape. So what is the reason why it can be hammered into shape? Because metals also have layers, and these layers can slide over each other. That's why D is the right answer. That metal is having a layer of the positive ions, and when we hammer the metal, actually these layers are moving from one place to another or over each other. That's why the metals are malleable. Next, which substance exists as a lattice of a positive ion and a sea of electrons? So basically they're asking about the metal. So a liquid sodium chloride, a metal and a non-metal, it will be ionic. So solid graphite does not have a positive ion and the sea of electron. Solid magnesium, because magnesium is a metal and all the metals have the similar structure. So C will be the right answer. Why not D? Because silicon 4 oxide is a macromolecule. Like the structure of silicon 4 oxide, each silicon bonded with 4 oxygen and the structure continues. So it's a very giant structure for silicon 4 oxide. So whenever they are asking for positive ion and sea of electron, means they're asking for metal. And when we check the option, we have magnesium in this example as the only metal. Graphite, which is carbon, and that is a non-metal. Which statement about the metal is not correct or not true? Metals are malleable because a metal ion can slide over each other. That's true. We have to find which is not true. Metal conducts electricity because electrons can move through the lattice. That is also true. Metal consists of a giant lattice of metal ion or positive ion in the sea of electron. That is also true. And metals have high melting point because strong attraction between metal ions. That is wrong. Why this is wrong? Why metals have a high melting point? Because they have a giant structure and they have a strong attraction between the positive ions and the sea of electrons. Because positive ions are like charges. If you have two positive charges, they will not attract each other. they will repel. But in the question they're saying it is having a high melting point because strong attraction between metal ion. So metal ions are not attracting, basically metal ion are attracting the electrons and they have a strong attraction. That's why the metals have a high melting point. Which statement describe the metallic bonding? So for question 5, which statement describe the metallic bonding? Attraction between the lattice of negative ion, that's wrong, and proton. Basically, it is the attraction between the lattice of a positive ion and the delocalized. The term delocalized means electrons are not having a specific position or electrons are free to move within the structure. That's why B is the right answer. And the previous was D because the question was which was not correct. The diagram shows a metallic bonding. So what is this? This one is a positive ion. And what is Y? Y is a electron. So which label are correct? What X is representing? X is representing, it can be a metal ion. You can say a metal ion because metal ions are also positive, or you can say it is a positive ion. So either C will be answer or D. But what about label Y? Label Y in metal is not the negative ion, is actually the mobile electron or electrons which can move easily. That's why C is the right answer. Substance X is solid at room temperature. It has high melting point, and solid X conduct electricity. So all these are the properties of metal. So which one, when we work out, B is the ionic structure, C is a giant macromolecular structure, D is a simple covalent structure, D was simple covalent, C was giant covalent. And what about A? A is a structure of a metal which is having a positive ion and a sea of electron. That's why A is the right answer. Question 8. Iron is a metal. Its structure consists of a giant lattice of a positive ion and the free electrons. Which statement about the solid iron are correct? Iron conduct electricity because it is having free electron. That's correct. Iron conduct heat because of positive ion are free to move. These positive ions are not free to move. The positive ions can only vibrate. They can only vibrate, but they're not free to move from one place to another. So this statement is wrong. Iron has high melting point due to strong covalent bond. That's wrong. It is not having a covalent bond. It is having a metallic bond, which is between the positive ion and electron. And iron is malleable, or metals are malleable because the layers of iron can slide over each other. So statement 1 and statement 4 are correct. That's why B is the right answer. And this question 9 is repeated. Why metals are malleable? So actually this fourth statement of iron is the answer. Why metals are malleable? Because the layers of iron can slide over each other. So layer of ions or positive ions can slide over each other. That's why D is the right answer for 9. In question 10, which statement describe the lattice structure of a metal? So what metal consists of? Metal consists of positive ion in the sea of electron. That's why option C is the right answer. Is it clear, the first 10 MCQs? Anyone having a doubt or want me to repeat any question? You can let me know. The first 10 MCQs. So in metal or metallic bonding, you will find the questions are repeated. Question 3. The question is, which substance exists as a lattice of a positive ion and sea of electron? So a lattice of positive ion and sea of electron. So basically they're asking about the metal. Which substance is a metal? Potassium chloride is not a metal, it is ionic compound. Because how we identify it is ionic compound? Because it is a combination of metal and non-metal. Solid graphite, it is a giant covalent. When you check the periodic table, magnesium it is a metal, and silicon 4 oxide is also a giant covalent. So which substance having a positive ion in a sea of electron, or which substance is having a metallic structure? That is option C, solid magnesium. Is it clear? So we just have to identify the metal from the options. Then the structure questions. Gallium is a metallic element in group 3. It is similar properties of that of aluminum. Describe the structure and bonding of metallic elements. So, and it is of 3 marks. So how you should include a label diagram. So when they say include a label diagram, so what you will do, you will draw a lattice of a positive ion. So these all are positive ion. And the delocalized electrons which are free to move within the structure. So you can shade this region, or you can write these E electron, and it should be labeled. So how you label? This will be a metal ion, you can write metal ion, or you can write positive ion, and the other one will be electron. So how we explain this structure, we mentioned it consists of a lattice of positive ion in sea of mobile electron or delocalized electrons held together by strong. The force between the ions is known as electrostatic force. So we can say held together by strong electrostatic force between positive ions and electrons. So whenever there is a force between the charges like positive and negative charges, positive charges or negative charges alone, so what we call that force as an electrostatic force. The force between the charges, like when you have a positive charge and you have electron, the attraction between them is called electro means charge and static means rest, so that's called electrostatic force. Even you have a positive ion and negative ion, because these are charges, so what we call this force, we call this electrostatic force. But if it is between the electrostatic force between positive and negative ion is known as ionic bond, but electrostatic force between positive ion and electron is called metallic bond. So both are electrostatic forces, but between the positive and negative ion, this electrostatic force is known as ionic bond. And between the positive ion and electron, electrostatic force is known as the metallic bond. Explain why metals such as gallium is a good conductor. So what is the reason why metals are good conductor? Because it is having a free electron, or you can say delocalized electrons, or you can say mobile electrons. Then magnesium is a metal. Describe structure and bonding of magnesium. So it will be a same answer here. Because metal consists of a lattice of a positive ion and the free electrons. So if they ask explain the structure of and the bonding of the metal, then the same answer you will write, that it is having a lattice of positive ion in a sea of electron held together by strong electrostatic force between the positive ion and electron. Yeah, it's of 3 marks. So what is the mark distribution here? The same way the mark distribution, 1 mark is for mentioning the positive ion. So when you mention positive ion, you will get 1 mark. 1 mark is for mentioning a sea of electron, and 1 mark is for mentioning electrostatic force between positive ion and sea of electron. That's how the marks are distributed. Then why magnesium conduct electricity when solid? So in solid state, it is having free electrons. 1 mark is for mentioning electrons, and the second mark can move through the lattice. So these electrons can move through the lattice. That's why the metals can conduct electricity. And then why metals are malleable? The layer of can slide over each other. The layer of positive ion can slide or slip pass over each other. So when you write layers can slide over each other, you will get 1 mark. And what is the second mark? There is a strong force between the layers, so the metal does not break or crack. So first thing, the positive layer of the positive ion. Here I should write layers of ions, not only layers. So layers of positive ions can slide over each other, and there's a strong force between the layers, so the metal does not crack or it does not break. So this is 1 mark. This will be the second mark. In question 3, the table gives some information about 5 substances. Now you have to identify from the properties, because substance can be ionic, it can be a covalent, it can be a giant covalent, or it can be a macromolecular. So if we try to work out the type of substance, when substance F, if we check their state at room temperature is about 25. So 25 will come between the melting and the boiling point. So substance F will be a liquid. Substance G, where 25 will come before the melting point, so it will be a solid. Substance H, the 25. So we are first identifying their state at room temperature. So that is solid. This will be liquid, and this will also be solid. Solubility in water. Ionic compounds. What are the properties of ionic compound? Ionic compounds are water soluble, and ionic compounds are solid at room temperature. So first the substance should be soluble. Substance should be solid. So which substance could be ionic? It can be G, it can be H, it can be J. This is first possibility. Then the substance should be soluble in water. So it cannot be G. Why? Because G is insoluble. Ionic compounds are water soluble. So it cannot be G. When you check S, it is soluble and J is also not soluble. So which substance is the ionic compound? The substance which follow the properties of ionic substances, so it will be H. So what we did, we work out the properties, like working out, because to be an ionic compound, it should be water soluble. So F and H both are water soluble, but it should be solid at room temperature. But F is liquid at room temperature and H is solid. So we work out that H is an ionic compound, or it will have an ionic bonding. Then the second part, which substance in the table has a giant covalent structure? For a giant covalent structure, it should be solid. It should be insoluble in water. And conduction of electricity does not conduct electricity except for graphite. If it was graphite, that only it can conduct, otherwise it does not conduct. So when we check, substance H is already an ionic. So we are left with option G and J. So for a giant covalent structure, the substance should be insoluble in water. It does not conduct electricity in either in a molten form, melted form, or in a solid state. So that's why G is the right answer. Why not J? Even J is insoluble, but it is conducting electricity in a solid as well as in a molten form. So basically J is a metal and G is a giant covalent. Then name a method which could be used to separate J from water. So they mention J is insoluble in water. If something is insoluble in water, which technique we can use to remove from the water? So we can use filtration. Then name a method which could be used to obtain F from a mixture of F and water. So how we can obtain, this is related to separation method, separation technique. F is a liquid and it is dissolved in water. So if two liquids are miscible, because if very soluble, it means it is miscible. So if two liquids are miscible, which technique we use to separate them from each other? We use fractional distillation. So miscible substances, miscible liquids, the technique which we use, we call that as a fractional distillation. So on the basis of boiling point, we separate the two substances from each other. Describe how would you obtain a solid sample of H from a mixture of G and H. So we have a mixture of G and H. G is insoluble and H is soluble. So first what we do, because G and H, G is insoluble and H is soluble. So first we will add water and stir or mix. G will or H will dissolve and G remain insoluble. So how we separate G from H? We will use filtration to remove G as residue which is left on the filter paper, and the filtrate is solution of H. And then how we remove this H from the mixture. So we can use evaporation, or you can use crystallization. So you can mention any one of them. You can mention use evaporation, to remove H from water. Because when we carry out evaporation, H will remain. So if I draw this, first we have a filter funnel here. In the beginning, we have a mixture of G and H. So when we carry out the filtration, G will left on the filter paper and H will pass through, but that will be a solution of H. And then we evaporate this, apply heat. So when water will evaporate, what we are left with? We are left with H. Substance J is a metal. Describe how substance J is able to conduct electricity when solid. So again, because if it's a metal, it has a free electron which can move through the structure. So free electron which can move through the structure. That's why substance J can conduct electricity. Then question 4. Beryllium is a metallic element in group 2. Give the electronic structure of beryllium. Beryllium, you will use the periodic table, you'll find beryllium is 4 and 9, so atomic number is 4. So if atomic number is 4, beryllium atom will have 4 electrons as well. So the first shell, it will have 2 electrons, and the second shell, it will also have 2. Give the formula of beryllium oxide. So how we work out the beryllium oxide? Beryllium belongs to group 2, so it will be +2, and oxygen belongs to group 6, so it will be -2. Then we simplify the valency, so it will be 1 and 1. And when we cross multiply these valencies after simplification, so it will be BeO, beryllium oxide. Then describe the bonding in metallic elements such as beryllium. Include a label diagram. Again, you can see it's of 3 marks. So what is the mark distribution? Well, 1 mark is for mentioning the lattice of positive ion or lattice of metal ion. The second mark is for mentioning the free electrons. And third mark is for mentioning strong. You have to use the term strong electrostatic force between positive ion and electron. So these are the 3 points you should include in your answer. Then why metals such as beryllium? It's a good conductor. So you will mention because it is having free electron, which can move through the structure. So this was the last question related to the weekly homework exercise metallic bonding. Any other question or a doubt? If you want me to repeat any part, you can just let me know. Is it clear to everyone?